All right, so today we are going to talk about geometric sequences, but in the last lesson, just as a refresher, we talked about arithmetic sequences. Now, arithmetic sequences are a list of numbers or terms where the difference is always the same. So 1, 3, 5, 7, 9. The difference between each term is 2. So we call this the common difference, which is 2. Same thing over here. Even though the numbers are decreasing, this just shows us that our common difference is negative. So 28 plus negative 6, which is our common difference, equals 22. Same thing. The difference between each term is the same. We can use this formula to write an explicit formula to find any or n terms. So if we wanted to find the 50th term, I could substitute 50 for n, and it would equal the first term. So if we were using this sequence on the left, the first term is 1. So it'd be 1 plus 50 minus n, 1 times d, which is 2. So geometric sequences are very similar, except instead of having this common difference, we have the common ratio. So in a geometric sequence, the ratio between consecutive terms is always equal. This is a common ratio. The difference between a ratio and the difference is what we'll see in a second. So we have these two different sequences. Both of these are geometric sequences. How do I know it's a geometric sequence? Well, I can see that the difference or the change between each term is multiplying by 3. Because we're using multiplication here, we see that it's a common ratio, not a common difference. Because there is a common ratio between each term, we know that this is a geometric sequence. Here, the common ratio is 3. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27, and so on, because this is an infinite sequence. Here, while I'm noticing that the numbers are decreasing, I'm also noticing that every other number is negative. Well, all this means is that our common ratio here is negative 1/2. 96 times negative 1/2 equals negative 48. Negative 48 times negative 1/2 is 24, and so on. If we are ever struggling to find the common ratio in a geometric sequence, if you can't tell or you don't know it using mental math, we can always take any term and divide it by its previous term to find the common ratio. So for example, if we look at this first sequence, if I take 27, any term, and I divide it by its previous term, 9, 27 divided by 9 is 3. So the common ratio must be 3. I could do the same thing and prove that the common ratio is 3 by doing that with every other term. 9 divided by 3 is 3. 3 divided by 1 is 3. The common ratio is the same between every term. That's how we know it's a geometric sequence. Same thing here. If I look at this and I don't know what it is off the top of my head, no problem. I choose a term, negative 12, divided by its previous term, 24. Well, if I worked that out, I would see that it's negative 1/2. Just like arithmetic sequences, our geometric sequences also have an explicit formula. U sub n, or the nth term, so any term that we want, equals the first term times the common ratio to the n minus 1 power. Now, you do not need to memorize this formula because it is in the formula booklet. So on the IB exam and on our unit test, you will have this formula available to you. But you need to know when to use it. So you must know how to identify a geometric sequence, which we know is common ratio. Yeah? So just like I mentioned on the previous slide, you can always find the common ratio by dividing any term by its previous term. So let's look at a problem. Write the explicit formula for the nth term of this sequence. So if we're going to write an explicit formula, that means that I'm going to write a formula in terms of the nth term, which is exactly what it asks us to do. So that means that for u of n, I know that the first term, u sub 1, is 1. It's the first value in my sequence. So 1 times, now what is r? What is the common ratio here? Well, I can do 1/2 divided by its previous term of 1 to find the common ratio, or I can just look and see with mental math what is the common ratio. And for this common ratio, we know that it's 1/2. 1 times 1/2 equals 1/2. 1/2 times 1/2 equals 1/4, and so on. We can represent this as 1/2, or we could write 0.5. Doesn't matter. So let me write that in my formula. So 1/2 times n, I don't need to substitute anything because it's asking me to find it in terms of the nth term, minus 1. Now, I know that, so this is our equation, but I know that 1 times anything is just itself. So the most simplified version equals u, or the nth term equals 1/2 times, or to the n minus 1 power. So to answer this problem, this explicit formula for this sequence would be this. All right, let's try a new problem. So same thing, we are write the explicit formula for the nth term of this sequence. So explicit formula means we're going to write a formula in terms of the nth term. So let's see, I'm going to start my formula up here. The nth term equals, okay, first term, well, I can see that that is 3. Great. 3 times, so what is r? What is my common ratio? 3 times what equals -12? Or -12 times what equals 48? Or I can reverse. 48 divided by -12 equals what? And we know that our common ratio is -4. So the nth term equals 3 times -4 to the n. I don't need to substitute anything for n because it's asking us to write the formula in terms of the nth term, which is why we noted that here, to the n minus 1 power. So our explicit formula for this sequence is this.